Right. So before I actually joined Cisco, I was a Cisco customer, right? And I had some issues with troubleshooting networks, and I wanted to make it a little more simpler. So I did the wise thing that I had to do. I joined Cisco, right? And today we're going to talk about three things. Before we move ahead, just to wait, so this computer is not behaving correctly. Before we move ahead, just to introduce myself, my name is Nikhil Sharma. I'm the technical marketing engineer for UABU, which is the Catalyst 4500, 3750, 2960, all the access layer switches that you use. That's what I'm there for. I also have with me Rakesh.
Hi.
He's my manager. So there are 6 of us. He manages us. And apart from that, he's also responsible for iOS packaging, right? So how do we sort of put all these features together and ship them out for our customers? So he does all that tedious task as well. We also have Hari, who's the software engineer. A lot of what you see out here, he's the brains behind it, right? So, all the easy questions for me, hard questions for him. But what we're here to tell you about today is some innovations that we're coming out with on the Catalyst 4500 regarding network troubleshooting. And we talked to some of our customers, and we also got some feedback from our analysts like Forrester. They did a study, and they said that network administrators spend up to 28%, 1/3 of their day, just on troubleshooting. And I could completely relate to that. And they also specified that they spend a lot of troubleshooting or a lot of time on how to do or how to deploy next generation stuff, or technologies like telepresence, video, and those kind of things. So today I'm going to talk to you about some of those features that we're coming out with in a release which will come out in April last week for the Catalyst 4500. It'll have Mediatrace, which you just talked about, the IPSLA video operation, which we just saw in Collaboration Manager. I'll show you the secret sauce of how it works. So we'll discuss that, what the underlying structure is, how it works. I know you guys want more of the GUI stuff, but I'll also show you how it works on the CLI. The other thing that we're coming out with is being able to do a Wireshark capture right on the switch. So you already have span. The Catalyst 4500 does 8 span sessions bi-directional. But what we have done with the latest iOS XE release is to take that Wireshark binary, the T-Shark binary, and put it right on the iOS itself, while securing all the other functions. So we'll do a little bit of whiteboarding. I don't have a lot of slides today. I'm sorry. I just have 2 slides on each feature and a lot of whiteboarding and a demo for these 3 features. So what do we use them for? Like I said, for capacity planning, network validation. Is my network ready for video? I can use these IPSLA. Troubleshooting and fault isolation. I really need, I have my CIO on the line and his video call dropped, and I just need to find out what happened, what went wrong. Okay, so you have Mediatrace, you have Wireshark. So let's take a look at Wireshark first. Come on.
Quick question, is this Wireshark for the data plane or control plane?
Both.
Okay, so that's different from the 7000, which has Wireshark for the control plane only.
Right, so this you'll be able to do data plane and control plane, and it's the actual T-Shark binary. So all those 2000 protocols that you're able to do with Wireshark, you'll be able to do here, and I'll show them to you in the demo. So this is something which is new on iOS XE, only on the SOUP 7e. We couldn't do it on the predecessor, and when we whiteboard, I'll tell you why. It's a software process, okay? It's not hardware. So we need to be able to tell our customers that we have these filters. We have some core filters, ACLs, class maps that you can use, the standard QoS, as well as the Wireshark filters. So the regex that you use in Wireshark, you'll be able to use over here as well.
I'm sorry, those, I'd like to clarify, those aren't regex, those are
sorry,
Berkeley packet filters.
I'm sorry, my bad.
Sorry.
I was just working on a BGP problem in the morning, so it just carried over. It has the ability to capture all these packets in the standard PCAP file, right on the switch. You can view them right on the switch itself, or you can send them off using TFTP, SCP, whatever means, to your network management station or your PC. You can store them on the SD card on the PC or on the switch, on the SUP. The supervisor also has a USB stick, which works. So you'll be able to put the USB stick in and copy it over there as well and take it back to your PC.
So you're saying it doesn't crash and reboot them like you did the 2900Ss?
No.
Excellent. It's a good start.
All right.
Same capabilities on the L supervisor?
Yes. So there's a lot of I don't know. You'll probably get these slides as well. There's a lot of appendix slides on over here which talk about the product and all those things. And we have done third-party verification for Wireshark on the SUP 7E and the SUP 7 Lite. One is a Network World article. One is a Myrcom test report. So how does it work? So you have your standard traffic going from one PC or one source to the destination. As soon as you invoke Wireshark, which is an exec command, you don't need to go into config T or any of that kind of stuff. What it does is it starts copying the traffic which you specify through filters or those other methods to the Wireshark process, right? Once it does that, you have the ability to either send it off to your network management station or your PC, or you have the ability to view it right over here itself, right? Now, the question that a lot of customers ask me is, since this is a software switch product or a software switch process, if I use this, does it crash my spanning tree or OSPF or HSRP, which is already running? So what we have done is we have put, sort of taken this Wireshark binary and put it in its own memory space and its own CPU space. So our architecture allows us to have, can I use the whiteboard? So our product allows us to have up to 64 queues from the, to the CPU, and we only use one queue for Wireshark. The other queues are used for other processes, like spanning tree protocol, HSRP, OSPF, and those things. So if Wireshark is, pounding the CPU is still servicing those other queues, right?
Will you get some indication that you're losing packets?
You can apply a control plane policer, and then you can get indication of how many packets you're dropping. And we are not restricting this to like any particular media type. You can apply it to your gig interface, 10 gig, VLAN, port channel, all those things.
So is this essentially just an internal span?
You can think of it that way, but then the ability to just do an analysis right on the spot, right on the switch itself without hooking up all your span equipment.
Understood, but it's technically speaking just a
Yes.
local span, right?
Yes.
And then it's up to the performance of the CPU at how fast it can actually process the packets coming to it. The same way we would have with an external PC.
Exactly. So if you were to sort of span the entire port channel, since it is a software-based process, it might not capture all of the packets. But if you put in the right filters in, like say I'm only interested in SIP packets, then it'll capture all those SIP packets.
Are there any risk impacts to do with replicating packets in the fabric? If you're going to take a copy of the frame on the inbound port and then replicate it up to somewhere else, is there any internal risks in terms of?
No. So like we said, when we architected this whole process, we put it in a separate, bin itself or a separate queue. So whatever happens in that queue, it does not affect anything else happening on the. It's risk-free. The only thing that will happen is if you say, I want to capture everything that's going to the switch, it'll drop packets. It won't capture those packets, but it's not going to break your OSPF.
So you've done it in such a way that it's risk managed.
Yes.
Right.
Is it working?
This is actually
Actually, you know what? We'll just, in the interest of
I
time,
can see it being very, very
we'll just go ahead. The reason why we're able to do this is because we have a dual core CPU right on the SOUP, and we're using iOS XE. iOS XE is essentially using a Linux kernel underlying,
Yep.
and then a hardware abstraction layer, and then we have an iOS, running as a daemon itself using one core, and then the other core we're able to leverage for applications like Wireshark. And in the future, we'll continue to have different kind of applications coming. Wireshark was the first one. We wanted to get it out. We learned a lot of things. We sort of understood, how to sort of protect the CPU system processes. Now with that learning in place, it'll be much more easier for us to deploy future applications.
So is iOS XE running a MIP simulator?
Oh, so I'm sorry, which?
Is iOS XE running iOS in a MIP simulator?
Not exactly.
No.
It's running the exact iOS just as a daemon application.
Okay.
So
you
they-
have
there's a-
Linux sits over here, and then iOS runs over here. So the control plane and the data plane is managed by iOS. So there's a Linux
Yeah.
instance over here that.
But is it-
No. You have actually iOS running as a process under Linux.
Yeah.
Yeah, but it is the
It,
is the
it,
CPU
it's just compiled to run under Linux.
Yeah.
So there is some documentation.
Was it yeah?
There-
Is it
It's
MIPS
IOU
or
in production,
is it
yes.
MIPS or x86?
No. So,
Wait, is it running as a process under Linux, or does it just use Linux to start it,
It
and
is
then
running-
Yes,
instantiate it,
yes.
and then puts it in a different piece in different
See
hardware?
what that
Yes.
slide says?
Let's show the.
Yeah, 10 minutes.
It doesn't matter how it's done. That's the way
Because
it's
if
done.
iOS no longer controls the phone anymore. But iOS XE
so in the interest of time,
only runs the control.
Bump up the font, that'd be great. Yeah,
Sure.
big deal.
And stuff, but all the packet generation stuff happens elsewhere. Basically just CI.
we're using a Mac next time. But anyway, while this thing comes up, it's a single line command. You can just do, monitor capture interface, gig, direction, in, out, both. Where do you want to keep it? What kind of filters you want to apply to it, all in one line. And then the next thing, what you can do is just say start. Then you should cancel it.
Sorry, I asked.
So just take it out. Let's go to Mediatrace.
Windows is searching for a solution to the problem.
Yeah. Sorry about that. I really wanted to show this to you.
Pops up an ad.
Windows ever found the solution to the problem?
No.
Anyone?
Yes, if the response says get a Mac,
No, it's fine. Just kill it, man.
Get a Mac.
store that apple.com.
So while we're waiting for this, I do have a. Oh, never mind. It's back up.
Oh,
The introductory architectural overview, iOS XE.
oh well. Okay. So it's a single line command, like I told you. What I'm going to do is, in the interest of time, show you how it works.
Yes.
So this is like the brief display that you get. You can see I have like everything, H223, SIP. And if I want to look at something specific, so I'm only interested in the SIP and I'm interested in the details. I get the entire packet right here.
This has a very ASA-like feel. So it's already familiar and common with what we know and have used.
Right. Right, we wanted to maintain that whole look and feel that everybody's used to on Wireshark.
There is no web interface to it or anything like that.
Unfortunately, we can't put a web interface on the switch. But what we are looking for is sort of, if you have like a Wireshark running on your PC, streaming the Wireshark capture, just like span.
Okay. But it would be unicast to an IP address or something.
Yes.
Okay.
All right, so Mediatrace, you looked at it from a GUI perspective. There are a lot of things that Mediatrace does, right? It actually does not only trace the path, but anything that changes in the path, it's able to discover. And it just not only just discovers the the hops, the path, and everything, the whole RTP statistics and all those things, right? If something in between is resetting the DSCP, it'll tell you. If the path change, it will tell you. The underlying protocol that it works on is RSVP. So anytime a path change happens, RSVP automatically knows, and then we use that as the underlying mechanism instead of traceroute using ICMP, right? So there are a couple of things what happens. A device can be a requester or initiator, and or a responder. Requester is somebody who requests. Initiator is somebody who actually takes that request and converts it into the Mediatrace, commands and injects it onto the switch. And then responder is the one who responds with all the data or the statistics. There's another feature which is tied into this. Is called performance monitor. Now what that does is, let's say on a single switch, you define a profile that you want to capture RTP and everything. It's sort of like a QoS policy. What Mediatrace does, is that it applies that policy on all the hops that are in the path. So you don't have to do that manually, because in order to collect those statistics, you have to have those policies on those interfaces. Mediatrace does that for you. And if the path changes or there's a tear down or anything, it removes that config for you as well. You want to show? I'll show. Start with the hop.
Can you pre-script events for this? So say you made changes within your architecture, you could give it a list of parameters of, I effectively want to start at this location and test throughout the infrastructure, make sure paths exist and protocols and things are responding appropriately. So can you make it a fully scriptable event, or is it just kind of a single linear path?
So let me get it. So to do the configuration, you mean?
No, like
No?
I'm at an edge switch. I make massive changes in my core. A whole
Right.
policy change or something crazy happens.
Right.
I want to be able to do a quick validation. So I go back to the edge device where my clients are going to be accessing data from,
Right.
and I run a preset testing policy that goes up and it does a whole string of things. We've shown based on the product before that you can generate traffic, you can see the hops, you're at a deeper level, you're looking at flows. Can you kind of pre-script all that to go test all that different stuff and go, yeah, I'm good from a client perspective?
Yes, because what happens is the edge device will actually send out the policies. So even if you make a policy somewhere down in the path, and you can have multiple sessions, by the way. So you can have policy 1 for session 1, policy 2 for session 2. But if you make any of those changes within the same session, your edge device where the initiator is will change that policy over there.
Okay.
Yeah, but I don't think that you can discover the whole how big is the network, how many.
I'm not looking to discover, I'm looking to test.
Yeah, I'm saying
Yeah.
first of all, you need to discover how many links and how many devices you have.
Can you go up?
So I think we can have some another layer of like automation. We have
Okay.
event run. We have we should be able to script it and then.
5 minutes.
Right. So we just executed the command. We have some pre-configured. These are the statistics that you would see on the GUI for the Cisco Prime that you just saw. But right on the switch, if you want to do a quick troubleshooting, you can view all these hops. You could look at the ingress egress interface. What the host is, the actual name of the host, what the reachability address is if you want to telnet into it, what the drops, the interface statistics, the RTP statistics, the DSCP or the TTL of the actual data that's going through, and then similar statistics for the hop number 2. Can you go down? Hit enter a couple of times. Right, so what did you do there? And this is with what, two hops? Yeah. You want to jump into SLA? IPSLA? So I know we talked about IPSLA, how to generate synthetic traffic. No, just do it over here. You don't need slides. Yeah. Oh, it's not doing it. So while it's continuing to get statistics, so Mediatrace you can do one-time execution, or you can do it like a schedule where it's scheduling, and then the performance monitor underneath has MEBs that you can export to your network management station as well.
We've got 1 minute to wrap it up.
Yeah. Still not showing it? It takes 30 seconds. Okay. So talk to you about Wireshark, some of the things we're doing with hosting third-party applications, Mediatrace, some really quick troubleshooting stuff that you can do right on the switch itself. As you can see now, we have, this is what IPTV, right? Yeah, so this is like an IPTV camera, IPTV kind of traffic that was sent and received, and all the statistics that you need right here. So now you know how your network is ready to deploy video. If you have some issues, you can look at Mediatrace, and if you have even further issues, do a Wireshark capture and figure out, maybe you're expecting an HD call, but these guys are only negotiating a 720 or a non-HD or a standard kind of a thing. So, some of these tools will definitely help our customers.
Thank you.
Thanks.
Thank you.